first calculator at negative 250 like we've all been taught. I've left the second calculator at the default setting, which is negative 10 and 10. Negative 10 and 10. And if you notice, I put the same equation in, but you get a much clearer picture as to where this line is crossing the graph on this one than you do this one. The problem and why we have you change your windows to 250 is because if you're trying to solve an equation and the answer choice was more than 10, it would give you a default on this one. Whereas this one, it would give you a default on this one, whereas this one, as long as the answer choice is somewhere between negative 250 and 250, it would give you the correct answer, all right? And that's why we have you do that when we're solving an equation. When we're solving a system, you're looking for more like where do the two lines cross? And sometimes they just give you a graph, and and they don't give you points, they just give you 4 different graphs. And so if you can see it from a graph, oh, it's right here, it looks much more like this one than this one, then that's why it's important to do this, okay? So I'm sorry. Let's just, I'm trying to come up with a number that would make sense.
84.
No. I want to see what this looks like at negative 100, 100.
It's weird.
Yeah, it's very weird. You did
I know.
100
Negative 100 and 100. See, it comes in, it looks like it's in the origin, and it's not. Okay? So, 50. It's got to be 10 and 10. So when you're solving an equation, my suggestion is that when you're solving x is equal to this, you want to set your windows at 250. If you're not solving for an equation, just leave them at default. Can you guys remember that? How about that? Okay? So everybody just reset your calculators. For systems of equations, we are going to leave our calculators at default. Okay? So you're just going to, when you start working on a calculator, if you clear it every time, it will be on default. And if you go to answer a question over x equals this, what will x equal? Then that's when you want to open your windows to include whatever your answer choices are. And we've just chosen 250 as a good earmark because that'll cover anything you might ever have. Okay? So, for systems of equations or questions like this where you're not solving for x, we want you to just leave it on default. A math teacher instructed students to graph the following equations on a coordinate plane. If graphed correctly, at what point will the two lines intersect on the coordinate plane? So what we're going to do here is we're going to go to y equals, okay? And what I'm going to do is put the first equation in, 2.5x plus 2. I'm going to go to y2 and put in 2x plus 4. Now, before I hit anything else, I am going to make sure that these two equations are put in correctly, because if you do not put them in correctly, you will get the wrong answer, and we don't want that. So make sure you do that, okay? Make sure you double check that they are correct. So we've been given points, haven't we? Now, most of you know hit graph, wait for your two lines, okay?
That's default, isn't it?
Okay, that's default, okay? So, now, you see how they're crossing somewhere up here, aren't they? Okay, so if I hit second and graph, it gives me the table, okay? This blue one is for the first equation because I put it in and it's the first equation. This is for the second equation, all right? So I'm looking for one of these ordered pairs. So I can toggle up with my arrows to look at my different points that these have. And what you're looking for is when y is the same is where these lines cross. And the easiest way to do is just go to your answer choice. Okay, do I have 0 and 4 and 0 and 4? No. So it can't be A. On B, do I have 2 and 8 and 2 and 8? No. I have 2, 7, 2, 8, don't I? Do you see that? When x is 2,
Ooh.
y1 is 7, y2 is 8, so it can't be that one. On C, 3 and 10? Nope. 3 and 9.5 and 10. Here, D, 4 and 12, 4 and 12, don't I? So that's my answer choice. That is where those two lines are going to intersect, and that is the solution to two equations. Okay? Where those two lines intersect. Easy enough? Okay, now I'm going to teach you a different cheat. If you're not looking at a graph for your answer choices, if you're looking at just something that you want to use the table for, don't do this. I'm going to change it, and I'm going to come down here and change that one just for the heck of it. Because then you know that it hasn't been graphed. All right? I can just hit second and table. I don't have to wait for a graph. Okay? And I can pull that table up, and it will give me the coordinate points where those two cross. The only problem you have is if x is not a whole number, because it only gives you x's as whole numbers. It will give you y as parts, but it will only give you x's as whole numbers. All right? So as long as your x's are whole numbers, you're good to go. Okay? All right. Let's look at number 2. This time, you can go about this one, the easiest way to go about this one, 2 different ways. I'm going to show you how I would do it, and then I'm going to let you decide, and I'll show you the alternate way you could do it. They're saying a student correctly graphed 2 linear equations, which means they put 2 lines on a graph, and saw that the lines intersected at 3 and 4.75 on the coordinate plane. Which pair of equations did the student graph? Okay, you can do this one either way. All right, I'm going to go back to y equals, and I'm going to clear both my y1 and my y2. Okay. All right, I'm going to put on A, I'm going to put 4x plus 4, and then I'm going to put 2x plus 3. Okay. If they're just giving me equations as answers, and I have to pick the equation that's right, I've double checked to make sure they're correct. And I'm going to hit second and table. And what am I looking for on second and table?
The ones where they're the same.
Where x is 3, go to where x is 3. Is both your y values 4.75? No. So can this pair of equations have this as a solution? No. So then you know that it's not A. Go back to y equals. All right, how do I put a fraction in the calculator?
Divide. Parentheses. Divide.
So you have to put parentheses. If you don't, you'll be in trouble. X divided, oops, I put a plus sign, divided by 2, close the parentheses, plus 0.5. Then I go to y2 and put 2x minus 1.25. And what am I going to hit? Second and graph to get my table. And what am I looking for?
Your y's to be the same.
No.
On 3.
Where x is 3, I have to have both my y's be 4.75. I have one of them, don't I? But is the other one that? No. So I know it can't be that one. Ooh. Now, look at this. I know that the second one was correct, right? It's the same equation, isn't it? Okay. So now, what do I got here? I'm just going to go to y equals. And I'm going to hit clear, and I'm going to put parentheses, x divided by 4, close my parentheses, plus 4. Do I need to change the second one? No, because it's the same equation. And I'm going to hit what, Braylon? I hope you're doing this with us because you're sitting over there blowing on a bag or something instead chewing on a wrapper. All right. Okay, then get your calculator, get that out of your hand and get your calculator working and your pencil working. Okay? And hit second and graph, and then is that my solution?
Yes.
Why?
Because at the third one, they're both 4.7.
When x is 3, both y's are 4.75, and that's what you're looking for. So then that's your solution. I don't even bother checking the second one, okay? All right, so that's how you deal with it when they give you points and you have all these equations. That's the easiest way to deal with it. All right, now here they've given me a graph. You can do this one of two ways. On this one, the easiest, well, actually, there's only one way you can do this. What is this point right here? You have to be able to read a graph. What is it? Negative 2, what? 2. Remember, x is always first, y is second. So you either go left or right first, then you go up or down. So here's negative 2, 2, it's B. Okay? All right, over here. If the two linear equations are this, graph, blah, blah, blah. Okay, you could do this by putting your two linear equations in. This is one that you have two choices. And you could go to your y equals, because if you're not good with graphs, that's probably the safest choice, okay? And you could put in 3x minus 7, and you could put in negative 2x plus 3, and you could hit second in table. And what am I looking for now? One of these points, right? So when x is 4, is both y's negative 5? Really? No. When x is 1, are both y's 1? No. When x is 2, are both y's negative 1?
Yes.
So that is my answer. That is one way. If you are not good with graphs, that is another way to check it. You can also just say, okay, this is at point 2, negative 1, and that would be my solution. Okay? So those are the 4 types of problems you're going to see on your paper today. And these are how you are going to attack and do this. And I know it looks long. This one, look at, you've got 2 equations. In fact, I will do, this is number 11, okay? You've got 2 equations, but you've got 4 graphs. And I know you don't have number 11, so I'm going to hand this out to you, and then you can open up your paper to number 11 and do it with me. All right, number 11. All right. You've got 2 equations but 4 graphs. So this is where you can go to y equals and put in x plus 4 under y1, and you can put 2x plus 2 under y2. Everybody's done this in their calculator? I need you to do that, okay? It says x plus 4 on number 11. And it doesn't matter what order you put them in. If you would put in 2x plus 2 first and then x plus 4 second, it doesn't matter what order you put them in. You're going to get the same results. And then what am I hitting to see the graph?
Second graph.
No.
I
I just want to see a graph. Okay, that's one way you could do this. And if the graph is clear enough, because I have my windows at default, I can usually tell which one it looks most like. Sometimes it's hard. Do you see it's kind of hard to see on these 4 graphs? When you're looking at, you're going to have to look at your calculator. So I hope you put this in on your calculator and are looking at what you got on your calculator. Look, this is an interactive class. You don't just sit there and look at and do and circle answers. This is where you learn how to do it when we're practicing together, okay? So you need to be doing this with me, because if you notice, it's kind of hard to tell on this, isn't it? Now, I could sit here and do this. Oh, okay, because I'm a little more sophisticated than y'all. I could pretty much go down to say, okay, that's my x is 2. 1, 2, 3, 4, 5, 6. So it's at 2, 6. Okay? But what else I could do, because both of these, so there's a couple of these that look pretty close to me. This one and this one, C and D look pretty close, don't they? Don't they? Okay, so another solution I could do is go to my second in table and find where my y values are the same. Find my x value. So I know my point now is at 2, 6. That's what I'm looking for, where they intersect. And then I know it's not this one. I know it's not B. I can go to C and say 2, 6. That ain't going to work. Is this one going to work? 2, 6. Yes, it does. So it has to be D. So that is how I would solve it. Sometimes the graphs look completely different, and they're very easy to tell just from the graph, but sometimes they don't. So that's your lesson for today.